So we have an algebraic expression to simplify. When we have a sum or a difference and we square it, that's called a complete square. And so we're going to have to expand a complete square, then another one, and then subtract the algebraic expression. There is also one more term that is interesting here, and that is that 3x and 3x are the same, 5 and 5 are the same. The only difference is in this sign. When that happens, the two expressions are called conjugates of each other. So 3x plus 5 and 3x minus 5 are conjugates of each other. And we will see in algebra that conjugates are very useful. Because of the symmetries, there are lots of cancellations. And this is an example for that. So first, let us work out just 3x plus 5 squared. To square something means write it down twice and multiply. And now we FOIL. 3x times 3x is 9x squared. 3x times 5 is plus 15x. And 5 times 3x is another plus 15x. And then 5 times 5 is 25. In case of a complete square, O and I are identical, and therefore there is a doubling up going on here. So 3x plus 5 squared, when expanded, is 9x squared plus 30x plus 25. This should be margin work. Eventually, you're going to be able to perform this computation mentally and just go like this. From FOIL, 3x times 3x is 9x squared. Then O and I are going to be 3x times 5. That's 15x plus 15x. And then L will give us 25. So we're not going to need all this computation. Now let's compute the other complete square. To square something means write it down twice and multiply. And now we FOIL. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is another negative 15x. And finally, negative 5 times negative 5 is plus 25. We combine like terms. And as long as we are dealing with complete squares, O and I are identical, therefore they double up. And so, because we squared conjugates, they are very similar to each other. See, the only difference is between these signs. Now there is an error on this paper. This subtraction is for the entire complete square through x minus 5 squared, which means that we are subtracting the entire expression. This is very important. If we omit this parenthesis, we make an error that will result in getting the wrong sign here and here. If we don't use a parenthesis, we're not subtracting the entire expression, only its first term. Okay. I would advise against subtracting mentally at any time. I would recommend mentally adding. So let's just write this out. To subtract is to add the opposite. So we're going to add, but we're going to change all three signs. So this is going to be a negative, this is a positive, this is a negative. So we're going to have minus 9x squared plus 30x minus 25. And now let's combine like terms. 9x squared and negative 9x squared cancel out each other, and so do 25 and negative 25. So the only thing left standing is 30x plus 30x, which is 60x. This caused by the symmetries resulting from the fact that we're using conjugates, that these two expressions are conjugates. So the final answer is 60x. Thank you for watching.